All right, so let's continue on with finding sine, cosine, and tangents. We're going to now combine the last lesson with this one and look at our special right triangles. Okay, so here we go. So what are the sine, cosine, and tangent ratios for 30, 45, and 60 degree angles? In pre-calc, and maybe in the end of Algebra 2, you're going to learn something called the unit circle. This unit circle is based off of angles who have multiples of 0, 90, 30, 45, and 60, right? And it goes from 0 to 360 degrees, right? And you'll build this unit circle, and these trig ratio values, the sine, cosine, and tangent of these numbers, are used so often in higher level mathematics that you are supposed to memorize this unit circle, right? No calculator necessary. You just plug it in. You know, okay? And again, it's based off of the special right triangles you learned in lesson 8.1. So let's take a look at this. So let's use the 45, 45, 90 one first. So you can use either 45 degree angle. I'll use this one. So 1 is going to be the opposite. Excuse me. Square root of 2 is the hypotenuse. So 1 is my opposite. Square root of 2 is my hypotenuse. And then this one, again, helps build that angle, so it's going to be the adjacent. All right. So we're going to look for the sine, cosine, and tangent of 45 degrees. So the sine of 45 degrees is equal to opposite 1 over the hypotenuse square root of 2. Now, we talked about rationalizing, so we're going to do that. Multiply by the square root of 2, multiply by the square root of 2. This is the square root of 2 over, right? 1 times square root of 2 is just square root of 2. And the square root of 2 times the square root of 2 simplifies to just 2. That is the sine of 45 degrees. Okay? The cosine of 45 degrees will be very much the same because the adjacent side is also 1. The hypotenuse is square root of 2. We would rationalize, and you get the square root of 2 over 2. And so, I'm sorry, I forgot SOHCAHTOA, right? I'm just getting ahead of myself like you guys have been doing trig since you were born, right? SOHCAHTOA, so sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, and now we're going to do tangent. Tangent of 45 degrees, so the opposite side is 1, over the adjacent side is 1, which was 1. Perfect. So these are, again, when you get into pre-calc, it would be great that you have these memorized. These are the memorized sine, cosine, and tangent values of 45 degrees. Now, what I want to do is I want to show you in a calculator how this stuff is stored. Okay, so we're going to leave this. Let me clear that. Remember square root of 2 over 2. Okay, I'm going to open up Desmos graphing calculator. Now, one thing to remember with Desmos, right, is that up here there is a wrench. Angles can be measured in two units, at least in this class, or in your math class. You'll do degrees or what are called radians. So if you look here, right, up in this wrench, notice that radians is darkened, right? So as you get to higher level mathematics, you will do more in radians than you do in degrees, just because of the way we write it in terms of pi. It's just cleaner, I guess. So we have to change this to degrees. Every time you come back to Desmos, you got to do this. Every time. If you don't, you get it wrong. So now watch. I'm going to type in SIN for sine and 45. This is a memorized ratio. This is what the calculator knows, that any right triangle that has a 45 degree angle, the ratio of the opposite to the hypotenuse is going to be 0.707. Right? Now, we know the memorized value for the sine of 45. It's the square root of 2 over 2. Watch this. There's my fraction. Square root of 2. Ready? Drum roll, please. Divided by 2. Are you ready? Boom. It's the exact same thing. So these memorized values, right, we're like being the calculator, right? It's nicer looking. It's not a decimal. Now, what if I wanted the sine of 52 degrees or the sine of 37? No, it's not a memorized value. We use the calculator, right? But for a 45, a 30, and a 60, we have these memorized values that your future teachers are going to want you to remember. So practice now. Okay. All right, so let's come back to here. Okay. Thanks for going on that ride with me. So let's use this triangle and let's do 30 now. So here's my 30. So from 30, 1 is my opposite. This is my right angle, so 2 is my hypotenuse. And then the square root of 3 helps make the angle, so that's the adjacent. So the sine, and again, SOHCAHTOA, I'll rewrite it, SOHCAHTOA. So the sine of 30 is going to be the opposite 1 over the hypotenuse of 2. And that's good. It's 1/2. And again, if you type in sine of 30 in a calculator, it'll be 1/2, 0.5. Cosine of 30 degrees is the adjacent side, square root of 3, over the hypotenuse, which is 2. Awesome. Great. Again, don't have to rationalize. Square root is in the numerator. Awesome. And then the tangent of 30 degrees is going to be the opposite 1 over the adjacent square root of 3. And now we're in trouble. We got to square root in the denominator, got to rationalize, times square root of 3, times square root of 3. So the tangent of 30 degrees is the square root of 3 on top, and then the bottom simplifies to 3. And here are your memorized trig values for 30 degrees. And now let's do one more. I'm going to redraw this triangle here. So we have the right angle here. This is 60. This is 30. 2, 1, square root of 3. And now we're going to take a look at 60 degrees, right? So from 60, the square root of 3 is now the opposite. From this right angle, 2 is still the hypotenuse. But now the adjacent side is going to be 1 because it helps make the 60 degree, right? The adjacent is 1. So what is the sine of 60 degrees? Well, it's the opposite square root of 3 over the hypotenuse 2. Now notice, right, that the sine of 60 is equal to the cosine of 30. So notice that relationship there, right? Okay, the cosine of 60, the cosine of 60 degrees is equal to the adjacent 1 over the hypotenuse 2. So again, notice that the sine of 30 is equal to the cosine of 60. Again, those are the two acute angles in the right triangle together. And then the tangent of 60 degrees is the opposite square root of 3 over the adjacent, which is 1. And that's nice. The square root of 3 is up top, so no rationalizing. The 1 in the denominator does not matter, so that's just the square root of 3. And there are your trig values for 60 degrees. Okay. So again, if you can't memorize these yet, it's not the end of the world. You are going to be asked these on your homework, right? So again, I would suggest that you build the triangle and you try to draw it out and find it. It's good practice. All right, great. So this example ties into B, the next example, because of this idea of the 30 and 60 and their sine and cosine values. So hopefully this will be emphasized in the next example here. Okay, so it says, how are the sine and cosine of complementary angles related, right? Sine and cosine of complementary angles. So the question is, why in the world are they talking about complementary angles here, right? Well, if you look at the measure of angle A plus the measure of angle B plus the measure of angle C, we know that they're the three angles of a triangle. They add up to 180. Well, we know that the measure of angle C is 90 degrees. So if we take away 90 degrees on both sides, then we have the measure of angle A plus the measure of angle B equaling 90 degrees. This is the definition of complementary. When two angles add up to 90 degrees, that is complementary. So this is why in this problem with sine and cosine, we're looking at complementary angles, not necessarily supplementary angles. All right, so let's take a look at this triangle, and I'm going to draw the triangle again over here, because I want to look at angle A and angle B simultaneously, right? So here's C, right angle, there's A, there's angle B. And again, as I promised, the opposite sides are the lowercase letters. Okay. So again, we're going to use SOHCAHTOA to find our sine and cosine values. All right. So here we go. I'll use blue. So let's let this be the A triangle. So if angle A is my angle I'm looking at, then that is my opposite side. Right angle points to the hypotenuse, and then B is my adjacent side because it helps make angle A. Over here, I'll do it in blue. If B is the angle, so now that's my opposite side. So notice the opposite side switches. The hypotenuse is still the hypotenuse, but now because this side A makes up angle B, that's now the adjacent. So notice that your opposite and your adjacent switch, right? That's important. Okay, so let's do the sine and cosine for angle A. So the sine of angle A is equal to opposite over hypotenuse. So its opposite side is lowercase a, its hypotenuse is C. The cosine of angle A is equal to the adjacent over the hypotenuse. That's this lowercase b and lowercase c. Okay, now let's look at the sine and cosine for angle B over here. So the sine of B is equal to, okay, so the opposite side is B over the hypotenuse C, and the cosine of B is equal to the adjacent side A over the hypotenuse C. And you notice that the sine of A over C, is the cosine of B, and the cosine of A, B over C, is the sine of B. So complementary angles, the sine of one equals the cosine of other, and vice versa. So from here, you need to know that the sine of angle A will equal the cosine of angle B, and the cosine of angle A will equal the sine of angle B. That's what you need to remember. And this is a huge idea for the state test. They love this question for some reason. I don't know why. Whatever. So the sine of A equals the cosine of B, cosine of A equals sine of B. And that's, again, because of the idea that the adjacent and opposite sides switch based off the angle you're looking at. So I feel like that was a lot, so I'm going to stop, make a third video to cover the last two problems involving actually using trig to find missing pieces.